We are going to be reviewing quadratic functions today, and in particular we're going to look at on how to recognize quadratic functions if you have just a graph, if you have an equation, and then if you have a table of values, we're going to use finite differences to recognize whether something is a quadratic function or not. So in the past, you have seen some quadratic functions, and visually you can recognize quadratic functions if they look like a parabola. And just to refresh your memory, a parabola looks something like this. It's almost like a U. And we say that the parabola opens up, and then the other option is that the parabola opens down. So some function like this. Those are the only two options that we have. So if you don't have these two options, then it must be some other type of relation. If you're looking at an equation, you can recognize it just by observing whether it has an x squared. And what I mean by that is you could have an example of a simple function like this where y is equal to x squared. You could possibly have some other terms such as this, and that would still be a parabola, but the main thing is that you're looking at this part. So if it has an x squared in this format, you will know that it's a quadratic function. And last piece of information is in respect to when you have a table of values. What you're going to do when you have a table of values, you're going to perform finite differences. We will talk about the process of performing finite differences a little bit later on. The main thing is that if you have first differences that are the same, then you will have a linear function, and if you have second differences that are the same, then you will have a quadratic. So these two are important to us. If you don't get finite differences that are the same for linear or quadratic, there is a possibility that the relation that you have is some other function, but for us, we don't need to know that until later on. So on your second slide, you're going to see some basic characteristics of parabolas or quadratic functions. As you can see, this is the one that opens up. It will be exactly the same for the parabolas that open down, except there will be a change in the vertex. So as you can see, there is an axis of symmetry, which is unique to parabolas, in the sense that parabolas are very symmetric, so that if you cut them in half through the vertex with a vertical line, you can sort of fold them over and they will overlap. So because of that, left and right side are very symmetrical, and that axis of symmetry is a reflection point for the two halves. The other parts that are important are x-intercepts. So we have one that is here, and then we have another one over here. We will be talking about them when we talk about factored form later on. And the last thing is the vertex. Vertex in this case is the lowest point that we have on our parabola, so it is down here. However, if you have a parabola that opens downward, so something like this, your vertex will be a maximum point. So in the first example here, this is a minimum vertex, and in this one it will be a maximum point of the function. That brings us to first and second differences. As you can see here, we have two equations. One is linear, if you recognize, so this one would be linear, and this one would be quadratic. The process in determining whether they are quadratic or linear just based on their finite differences, well, would be the same, except you would have to do it twice for quadratics. So if you have a table of values, we could fill in the y values just by substituting the x values in our equation. So if If I go ahead and substitute -2 into my original function and calculate it, that will give me the first y value, which in this case is 14. So this will be 14 here. If you repeat it for every one of these x values, you can fill in the y column. Oops. You can fill in the y column of the table, and from there we can proceed to do first differences. If you remember from maybe grade 9 or grade 10, when you perform the first differences, the order is very important. So what I mean by that is you will take the numbers 2 at a time. What is important is that you're going to subtract the first number from the second number. So it's going to be 8 minus 14, and in this case that's equal to -6. And that is the order of performing. What you're going to do next is you're just going to slide down that pair, and you're going to take the two numbers, and again you're going to subtract in this case second number from the third number. So it's going to be 2 minus 8, which again will give you -6. If you repeat that for the other pairs of numbers, you will get that the first difference is -6 all the way through. Because that first difference is constant, it is -6 all the way through, we know that this is a linear function. You can repeat the same process with the quadratic. So if you substitute, I guess we can use -2, so it's going to be 2 times -2 squared plus 3 times -2 minus 1. In this case, you will get just 1, so my y value will be 1. If I repeat that for all the x values, I will get -2, -1, 4, and 13. Now, the process is the same for first and second differences. So in this case, it is important to keep track of signs. So we're going to have -2 minus 1, which will give me a -3 as a first number for the first difference calculation. Second two numbers, we're looking at -2 and -1. So we're going to combine those two. And this is where you have to keep track of signs. You have -1 minus -2. And that, if you punch in a calculator, maybe if you have to combine the two signs first, you will realize, if you look down here, it's -1 plus 2, which will be, in this case, 1. So that will be 1 right here. And if you repeat this calculation all the way through, you will get that this is 5 and 9. Now for second differences, you're going to repeat the process, but you're going to be using first differences for the calculation. So in our first one, we're going to subtract 1 minus -3, and we're going to get 4. And if we repeat that all the way through, we can fill out the first differences. So this one is going to be 4, and this one is going to be 4 as well. And as you can see, they're the same values, and as a result, we can confirm that yes, this is a quadratic function. That is the process for finite differences. If at any point you need to stop the video to copy these notes, you should do so. And if you look at the summary at the bottom in terms of first differences, just a reminder that if the first differences, if the first differences are the same, you have a linear function. If the first differences are not the same, you can keep trying for the second differences and see if you get the second difference is the same. If the second difference is the same, you will have a quadratic relation. I've left some practice questions here from the workbook and the textbook. If you have any questions, you can ask your supply teacher there. And I will see you on Monday.